All right, for today's lesson, we're going to review some L'Hopital's rule, and we're also going to do some tangent lines. If you haven't watched the first video on L'Hopital's rule, you should go ahead and watch that now. That was posted last week, so go watch the introductory video on L'Hopital's rule, and then we'll do a little practice on that and then introduce a new concept. So first, you should try these 4 L'Hopital's rule questions by yourself, and then I will go over how to do them by applying the rule. So you should pause the video. And if you're unpausing, that means we're now going over these and seeing how you did. So the idea with L'Hopital's rule is that if we're taking a limit, we can always try to just plug in what the limit is approaching and see what we get. In this case, if we do that, we get 2 cubed minus 8 over 2 minus 2, which is going to give us 0 over 0, which is an undefined value. So we can't just use that method of solving the limit. We can't just plug in like that. So what L'Hopital's rule says, though, is if you get 0 over 0 when you plug in your limit, that means you can take the derivative of the numerator and the denominator and then try to apply the limit again. So this is going to be equal to the limit as x approaches 2 of 3x squared minus 0 divided by 1 minus 0. Okay, so we've taken the derivative of the numerator and the denominator, and now these two limits are going to be equal. But now when we try to plug in 2, we're going to get a real value. So we do 3 times 2 squared over 1, which is going to give us 12. All right. So same thing here. If we try to plug in x equals 5, we're going to get 0 over 0. So what we should do is apply L'Hopital's rule. So we're going to do the limit as x approaches 5 of. So the derivative of 1 over x is one we've done before. To do this, we have to rewrite it as x to the negative 1, and then when we do our power rule, we're going to get negative 1 times x to the negative 2, which is negative 1 over x squared. So the derivative of 1 over x is negative 1 over x squared, minus the derivative of 1/5, that's just a constant, that'll give us 0, divided by 1 minus 0. So now we can just plug in our value of 5, and we're going to get negative 1 over 5 squared, which is negative 1 over 25. So that's what our limit's equal to. Okay, here if we try to plug in infinity, we're just going to get infinity over infinity. So we're going to do L'Hopital's rule. Okay, so we get 3x squared minus 16x over 4x cubed minus 4x minus 5. Okay. So then if we try to plug in infinity, we're still going to get infinity over infinity, so we're going to try again. So now we get the derivative of 3x squared is 6x minus 16 over 12x squared minus 4. Okay, we're still going to get infinity over infinity, so we try one more time. Limit as x approaches infinity. Okay, so derivative of 6x is 6 minus 0 over 24x. Okay, now if we plug in infinity, we get 6 over 24 times infinity, which is just 6 over infinity, which is equal to 0. Okay, so that was a long way of doing that using calculus, but you can also just use the reasoning we used in pre-calc, which was if the degree is bigger on bottom compared to top, then the bottom's going to become way bigger and we're going to approach 0. So that's a faster way of getting to the fact that the limit's 0. Okay, same thing here. With our pre-calc knowledge, we know that this should be 4/9. But we can just see how L'Hopital's rule applies here. If we plug in infinity, we get infinity over infinity, so we're going to do the derivative. We get 12x squared minus 4x over 27x squared minus 10x minus 2. Okay, infinity over infinity again, so we're going to do the limit as x approaches infinity of 24x minus 4 over 54x minus 10. Okay. One more time, because if we plug in infinity again, we're still going to get infinity over infinity. So this is going to give us 24 over 54, which does simplify to what did we start with here? 4 over 9. Simplifies to 4 over 9. Which again, we could have figured out without doing L'Hopital's rule, but that's just another way of thinking about it. Okay. So now we're going to talk about equations of tangent lines. So first think, how do we write a linear function? What is a linear equation of a line? And there's actually multiple different ways you've seen in the past in other math classes, but try to think of multiple ways. So just pause and think about that for a sec. Okay, so we have what we call slope-intercept form, because we have the slope of the line is m, and the y-intercept is b. So that's the y equals mx plus b. We have point-slope form, which is determined from a slope, m, and then a point, x1 comma y1. Okay, and this is standard form, which we're not going to get into as much. These are the two that we're more worried about here. And when it comes to constructing tangent lines, this is going to be the best one to work with. Y minus y1 equals m times x minus x1. And there's times where you may figure this out, but then the multiple choice question will ask for this form, in which case you're going to want to be able to go back and forth between the two. Okay, so let's do a couple examples of determining a line tangent to a curve. So we're dealing with the function x squared at x equals 3. So the first thing we want to think about is, can we determine the slope of x squared at x equals 3? Okay, remember x squared, it looks like, it's a parabola, right? And what we want to do is figure out the slope of this curve at x equals 3, but not just the slope, but the equation of the line. Because if we have like a slope of 2, right? Okay, that could look like this, or like this, or like this, or like this on a coordinate plane, right? All those lines have the same slope if I draw them perfectly, right? And they're at different points on the graph. They have different equations, same slope but different equations. So we want to find the specific one that's going to match with the equation of the tangent line at x equals 3 here. So if we're going to do y minus y1 equals m times x minus x1, what I've asked you to find already is m. I said, what is the slope of f of x at x equals 3? Okay, so that's just f prime x at the x value. So in this case, it would be f prime 3. So in general, it's f prime x. In this example, it's f prime 3. Okay. And then y1 is the output at the x value. So in general, f of x, but in this case, it's going to be f of 3. And then we have x1, which is just our x value, whatever. In this case, we have x1 equals 3 because we're saying at x equals 3. Okay. So we need to determine, we already know what x1 is. We know that that's 3. What we need to do is determine what the y value is and what the slope is. So we just plug the x value into the function to get the y value, right? So that's y minus 3 squared, which is y minus 9 equals. Okay, how did I get this 6? I did f prime x equals 2x. So f prime 3 equals 6. So that's our slope. And then x minus 3, because that was our given x value. So this is a function. This is the equation of the line tangent to the curve at x equals 3. So if you draw x squared, okay, then at x equals 3, if we were to plot this line, this is the equation of the line that's going to go exactly tangent to the curve at x equals 3. Okay. So let's try another one. X cubed at x equals negative 2. So you try to fill in the important information here. We have y minus y1 equals m times x minus x1. Okay, so pause and try, and then unpause and I'll go over. Okay, so let's go back here and do this step by step. Okay, so first we need to figure out what y1 is, and that's just going to be f of 3, right? Or sorry, f of negative 2, because we're plugging in negative 2. So that's y minus, so this is going to be negative 2 cubed, which is negative 8. So that's going to give us y plus 8 on this side. Okay. We don't know what m is yet, but we do know that x is negative 2, which when we subtract negative 2, that's going to give us plus 2, minus negative 2. Okay, so what's m? Well, m is going to be the derivative at x equals negative 2. So we do f prime x is equal to 3x squared by the power rule. And f prime negative 2 is going to be 3 times negative 2 squared, which is just 3 times 4, which is just 12. So this m value we should be plugging in is 12. So there it is. We have y plus 8 equals 12 times x plus 2. Again, this is the line that's going to be tangent to x cubed at x equals negative 2. At the point negative 2 comma negative 8, we're going to draw this line, and it's going to intersect that point and show us the slope. In this case, the slope is going to be 12. Okay. So here's a couple more to try. For this top one, you're going to need to know some trig values, and I could just make you go look them up. Again, we need to review trig at some point, but we just need to figure out the best time to do that. For now, maybe I can just tell you that sine of pi over 6 is 1/2. Remind you, because you've known this at one point. And then cosine pi over 6 is root 3 over 2. So those are going to be helpful pieces of information as you find the tangent line here, and then also do it for e to the x at x equals 4. So pause and give that a shot. Okay, if you're unpausing, you want to check answers. Okay, so we have y minus 1/2 equals root 3 over 2 times x minus pi over 6. Okay, so remember, this is just our x1. Okay, this is our m, and then this is our y1, right? So this represents sine, our function, at our x value, pi over 6. Okay, this represents the derivative, cosine, at pi over 6, because cosine is the derivative of sine. So we get y minus 1/2 equals root 3 over 2 times x minus pi over 6. Okay. So then if we want to do e, well, we know that the derivative of e to the x is just e to the x. So this is f prime 4, which is just e to the x with 4 plugged in. This is f of 4, which is the same thing as f prime 4, since e is its own derivative, right? And then 4 is just our x value. That's x1. So this is the line that's going to be tangent to the function e to the x at x equals 4. Okay, one last thing that I forgot to do on this last one. In the event that you get a multiple choice question where it's not in this format, what you're probably going to have to do is rewrite it in a different way by distributing. So you may get y plus 8 equals, distribute the 12, we get 12x plus 24. And then maybe you just have to subtract the 8 from both sides, so we get y equals 12x plus 24 minus 8 is 16. Okay, so this is what we call slope-intercept form, and sometimes a multiple choice question may be in this form. And so though it's easier to find it in this form, you may then have to convert it here for your multiple choice answer. Okay. Okay, so here's your closure. You have a L'Hopital's rule question and a tangent line question. So you should do this to your best of your ability, and then submit a picture to Google Classroom showing me what you learned in this lecture. And then you will have some day 7 practice assigned. They'll be due before the next class period as well. All right, nice job.